Okay, lesson 4, surface area. So we're doing surface area, but in this case we're going to be using 3D objects. Okay, so the first one we're going to examine is a rectangular prism. Now in a prism, the front and back are the same. Okay, think of any box, the front and the back are going to look exactly the same with the same dimensions. So if we use 5 for that distance measurement, and we use 2 for the vertical, we will get the dimensions of this rectangle. So if we do area is equal to length times width, that is just 5 times 2, which is 10. So 10 centimeters squared is the area of one of them. But if we take 10 and we multiply it by 2, because we have the front and the back, we get a total of 20 centimeters squared. So the front and the back are 20 centimeters squared. All right. Now the top and the bottom, so if we're thinking this part here, we kind of have to think, well, 5 by 3 is the measurement. So 5 and 3. So the area is 5 times 3. Now instead of kind of doing two separate calculations, I'm just going to multiply it by 2 for the top and, the top and the bottom. So the area is 5 times 3, which is 15, times 2, which is 30 centimeters squared. Okay. Now the right and the left, so these areas here, they're the same again. And so their measurements are going to be 2 by 3. So if we do area is equal to 2 times 3, and then we have two sides. So we multiply it by 2. So 2 times 3 is 6, times 2 is 12 centimeters squared. So the total is going to be 20 plus 30 plus 12 centimeters squared. And if you add that all up, you're going to get 62 centimeters squared. So using this kind of idea that, the top and the bottom are the same, the front and back are the same, and the right side and left side are the same, we can get this formula here. All right, so this is going to be like the front and back. This is going to be the top and bottom. And this is like the right side and left side. So we get all different sides in one formula here. So instead of using a big chart like this, you can just kind of condense it into one calculation. It makes your life a little bit easier. So we have, let's call that the length, the width, and the height. So if we use the same formula here, 2 times length times width, plus 2 times width times height, plus 2 times height and length. So let's plug in all our values. So surface area is equal to 2 times the length. So what's our L? So 9.4. And what's our W? That's 1.2. Plus 2. What's our width? 1.2. And our height, 0.7. And then our last calculation here, height and length. So our height is 0.7 and our length is 9.4. So if we get our calculator out here, 2 times 9.4 times 1.2 plus 2 times 1.2 times 0.7 plus 2 times 0.7 times 9.4. Might have to do that again. 2 times 9.4 times 1.2. So that part is 22.56. 2 times 1.2 times 0.7. That's 1.68. 2 times 0.7 times 9.4. 13.16. So let's add these together. So 13.16 plus 1.68 plus 22.56 gives us a total of 37.4 yards squared. So you'll notice that amount of work versus that table kind of condenses it a little bit. All right, let's do another example. So we have our length, our width, and our height. So 2 times width times length plus 2 times width times height plus 2 times length times height. So the width is 3.9, our height is 7.6, and then 2 times the length of 7.2 and the height of 7.6. So let's see if I can do this all in one big step here. So 2 times 3.9 times 7.2 plus 2 times 3.9 times 7.6. All right, plus 2 times 7.2 times 7.6 equals, and we have a total of 224.88 inches squared. All right, cylinder. We kind of have to find out some measurements. So I don't know if it's showing up in there. It looks like the radius is 4, or so the radius is 2. Oops. Sorry, we're going to use a radius of 4 centimeters. And so we're going to do pi times 4 squared. Now if we think of a cylinder as a top and a bottom, well there it is, radius of 4. There's 2 of them. So if we go pi times 4 squared times 2, this is going to be 100.5 centimeters squared. And then this one, the formula is 2 pi RH. Okay, so 2 times pi times the radius of 4 times the height of 6, and that will give us a total of 2 times pi times 4 times 6, oops, 2 times pi times 4 times 6. Let's try that again. So that one's 150.8 centimeters squared. So if we add that back to the circles, 100.5, you should get a total of 251.3 centimeters squared. The formula for a cylinder is 2 pi r squared plus 2 pi RH. So let's do another example here. This is supposed to be a diameter of 4 and a height of 9. So diameter of 4, which means our radius is 2. So we got to use that instead of 4 for the diameter. So surface area is equal to 2 pi r squared plus 2 pi RH. So that's 2 pi 2 squared plus 2 pi times 2 times the height of 9. 2 times pi times that plus 2 times pi times 2 times 9. So the total is looks like 138.2 centimeters squared. All right. Got another cylinder here. So our radius is 2, our height is 6. So let's use that same formula. 2 pi r squared plus 2 pi r h. So 2 times pi times 2 squared plus 2 times pi times 2 times 6. 2 times pi times 2 squared plus 2 times pi times 2 times 6. In this case, we get a surface area of 100.53 centimeters squared. All right, on to the triangular prism. So we have this front face and the back face, which are going to be the same. Okay, so we have two triangles that are 9 by 12. So if we use, base times height divided by 2 as the surface area of a triangle, let's take that into account. So we have 9 times, 9 and 12. So 9 times 12 equals that, and we divide it by 2 to get the surface area of one triangle. But we have two of them, so we multiply by 2 and we get back to where we were. So that's 108 centimeters squared. Then we have 3 different rectangles. Okay, we have the base, we have the back, and then we kind of have the top part. So the base is a 12 by 5. So that's just 12 times 5, which is 60 centimeters squared. The back is 9 times 5. 9 times 5 is 45 centimeters squared. And then the top is going to be 15 by 5. So 75. So we add that all up. 75 plus 45 plus 60 plus 108. We get 288 centimeters squared. So let's do an example here. We have the two triangles. So times 2. And then we have the front face, which is going to be 9 by 12. We have the back, which is 4 by 12. And then we have this one over here, which is 12 and 7. I know my drawings are not quite proportional. Let's try that one again. 7 and 12. Okay. So the 3 rectangles are fairly simple. You just multiply length times width. So let's do that one. That's 84. 4 times 12. This one's 48. And that's 108. The triangles are a little bit trickier. We need to use that base height that we're given of 3. And the base, in this case, is 9. So the triangles, they're just 9 times 3. You would divide by 2 for just one triangle, but you do have 2 of them. So it's just 9 times 3, which gives us 27. So we have 27 centimeters squared plus 84 centimeters squared plus 108 centimeters squared plus 48 centimeters squared. So the total, if you add all that up, is 27 plus 84 plus 108 plus 48 gives us 267. Okay. All right. Another example. Boy, there's a lot of examples. I'm going to skip example 6 because it's pretty much like example 5 and 4. So let's go straight to example 7. The surface area of a sphere formula is 4 pi r squared. So here it gives us the radius of 75. Here it gives us a diameter of 12. So the radius would be 6. So you go surface area is 4 times pi times 6 squared. Let me get the scientific. So 4 times pi times 6 squared. This one is 452.4 centimeters squared. Again, surface area 4 times pi times 75 squared. I think this is going to be a big number. 4 times pi times 75 squared. Yeah. 30. Oops, erased it. 4 times, oh, there it is. 70,685.8 centimeters squared. Okay, so here's a summary of the formulas. You need to use this when you're doing the classwork. So refer here, figure out which formula you need, and then use that in the calculations.